Hello, and welcome to this lecture. In this lecture, we will look at builds in more detail. We will be covering the various build strategies available in OpenShift, as well as look at how to view existing build configurations, and also how to create a new build configuration. The build configuration will be viewed and created using YAML files, so knowledge on YAML file is recommended. If you are not familiar with the YAML language, don't worry. At the end of this course, in the appendix section, we have a video lecture and some fun coding exercises on YAML that will help you get familiarized with it. In case you haven't worked with YAML before, I highly recommend going through that first. We looked at builds at a high level in the previous lecture. Let's look at it in a bit more detail. Say we have a simple Python web application developed using the Flask framework, and all that it does is display a web page with the welcome message. We know that Kubernetes expects a Docker image of this application, so we need the build process to convert this application into a Docker image. If you were asked to build a Docker image to package this application code, what would you do? From what we learned about Docker in the past, we would create a Docker file with a set of instructions. In this case, we start with an Ubuntu OS and install Python and pip packages. We then install Flask and copy the application code into the image and finally specify the entry point to run the application. We then place it next to the application code and run the docker build command, and that would create the Docker image for us. Now that's one build strategy supported by OpenShift, and it is simply called the Docker build. This, however, requires us to provide the list of instructions required to build the Docker image in a Docker file alongside the application code in the source code repository. When the build job runs, OpenShift will automatically create a Docker image using this Docker file. The image is then pushed to the internal Docker registry. The other build strategy is called source-to-image build strategy. Source-to-image is a framework that takes your application code and converts it into a reusable Docker image, without you having to provide the instructions in a Docker file. The S2I tool creates the image for you, without having to build a Docker file to create the image. It uses a pre-built Python builder image and injects the application code into it to create the final application image. In the previous exercise, when we deployed the application using the Python catalog item, it automatically created a build configuration of type source-to-image build. If you need to modify the build strategy, you must edit the build configuration from the web console interface or from a YAML file. So far, we talked about building Docker images, but what if you really need to build individual artifacts, like jar files, Python packages, or gem files? You could use Custom Builder for this purpose. This is, however, an advanced topic, and we will hopefully cover this in an advanced course. In the source-to-image build strategy, we discussed that OpenShift uses a pre-built Python builder image and merges the code into it to generate the final Docker image of the application. I could have different types of such pre-built images to be used by my applications. For example, I could have an image for each of my application types, such as Java, Python, Ruby, etc. For my Python image, I am good to go with the default Python image available on the public Docker Hub registry. However, for my Java image, I need to use a custom image placed in the internal Docker registry within the OpenShift environment. My Ruby image must come from some other private registry hosted within my organization. If this is my requirement, I would need to refer to these images in my build configuration using different naming schemes like this. The internal registry is located at 172.30.1.1. The public Docker Hub repository is at docker.io, etc. Moreover, relying on images like this has its own risk. For instance, if the Python 27 image on Docker Hub gets updated without our knowledge, which it often will, those updates can impact our application in unexpected ways. To prevent such scenarios and to provide a consistent referencing technique for Docker images, OpenShift introduced image streams. Image streams map actual Docker images hosted at different locations to image names within projects in OpenShift. This way, all of my dependent images for Java, Python, and Ruby now have a consistent reference, and the actual location of these images is abstracted by image stream. When an image is created by image stream, it does not really point to the target image by the name. Instead, it points to the image ID, which is unique across builds. This way, even if the Python image on the target gets updated, it still points to the previous known good image using the image ID. However, note that the image stream can be updated as and when required. As you can see, image streams are just pointers to the actual Docker image, and they are not Docker images themselves. Image streams are only metadata that provides us with a layer of abstraction for referencing Docker images from within OpenShift. We talked about various build strategies, but how do you create a new build configuration? For example, we have already seen the source-to-image build strategy created by OpenShift. If you select the Build in the Web Console and select the Configuration tab, you will see details about the build configuration such as the build strategy, which happens to be source, meaning source-to-image. We can also see the URL of the GitHub repository and the Python image that will be used by the S2I tool to package application. Once the build is successful, the final Docker image is pushed to the internal Docker registry at address testproject/simple-webapp-docker. On the top right corner of the user interface, you can see an Actions button, which has a few options such as Edit and Edit YAML. Clicking the Edit YAML option provides us with the build configuration in a YAML format. The kind and APA version defines the object we are viewing, which is a build configuration. The strategy type happens to be source. The URL of the code is specified under the source Git section of the file. The reason we are looking at the YAML-based build config file is so we can create a new one ourselves to create a new build configuration. We will now create a new build configuration using Docker build. For this, we will reuse the S2I YAML file and modify it to suit our needs. To start with, we will give the build configuration a new name, Simple Web App Docker, to differentiate this build from the existing one in the UI. Second, we will modify the source to use a new repository with the Docker file in it. We need a Docker file in this case, as we are planning to use the Docker build strategy. This is the Simple Web App Docker GitHub repository. Then, the strategy type is now going to be Docker instead of source. Also specify the source image to build the application from, which in this case happens to be Ubuntu 16.04. The output is going to be an image stream tag. We will use the same image stream for now. Once the YAML configuration file is ready, to create a new build configuration, click on the Add to Project button on the top right corner of the project window. It has a Import YAML option. Selecting that option will bring up the Import wizard. Copy the contents of the Docker build config YAML file into the interface and click on Create. This will add a new build configuration. Opening the new build configuration will show you that the build strategy is set to Docker, and the new source repository containing Docker file is used. You may start a build manually by clicking on the Start Build button. This will trigger a new build. If you try to build again and there is a build already in progress, it will add the new build into the queue and wait for the previous build to finish. Let us now take a demo of builds in OpenShift.